In this video, we're going to look at an exam question focusing on moments. Pause the video now and try all parts of this question. So part A says define the moment of a force about a pivot. Usually in physics, when it says define, it means write down the formula in words, if there is a formula, and here there is. So the definition is force times by perpendicular distance to the pivot. And all bits of this are important. Perpendicular is important, and to the pivot is also important. BI says label the forces on the bridge. So first thing we always need to add, and it's really good to put this on first so we don't forget, is the weight of the bridge itself. And it actually tells you that the plank is 2 meters long and it weighs 30 newtons. So we can just write down 30 straight away. We also have the weight of the toy. And again, it tells us the weight is 15 newtons. So we can just write that. We don't need to write mg. Then we've got the tension in A. That was actually already labeled on the bridge. I'm just going to write TA, and then the tension B as well. And importantly, the bridge, spelt completely wrong, the bridge does not touch a shaded block. So there's no resultant force, there's no reaction force up here. So these are the only 4 forces we need to take into account. Part II, we're going to be taking moments about P. And I stupidly left off point P from the diagram. So bonus points if you figured out that point P has to be here. If we want the tension in A, then the quickest and easiest way to do this is to take moments about point P here, because then we eliminate the tension B because there is no moment. So it's in equilibrium. So we know that the clockwise moments are balanced by the anti-clockwise moments. So now we can start to write down our expression. So the 30 newtons times by this distance here, which is going to be, well, we've got this is 1.2, this is 0.9. So this distance here must be 0.3 meters. Sorry, that's not right. 0.2 meters. That's 1.1. So times by 0.2 plus this 15. Sorry, I've got this completely wrong. Right, let's start again. We've got the 15 newtons times by 0.2. All right, because this is 0.9, this is 1.1. Plus the 30 newtons times by this distance here. So what is this distance? Well, we've got the entire length from here to here is 2 meters. And the length from here to here is 1.1 meters, which means that this missing distance here must be 0.9 meters. And the center of mass obviously acts at exactly 1 meter along. So this distance here must be 0.1 meters. So what did I just say it was? It was going to be 1. So it's 0.1 meters. So what have they done, or what have I done? A bit of a mistake, but it does check you're awake. I've drawn this diagram wrong. It's clearly not to scale. This, if this distance here is 0.1 and this distance is 0.2, then clearly there's something wrong in this diagram. The car should actually be over here. So if you backed yourself with that, well done. Now, what's the moment in the other direction? We've got our tension A times by this distance, which is 0.8 meters. So now we can rearrange for the tension in A. So 15 times 0.2 plus 30 times 0.1 divided by 0.8 gives us a tension of 7.5 newtons. In part 3, calculate the tension in B. So there's 2 ways to do this. The first way is to realize that the 2 up forces are going to equal the sum of the downwards forces. We know that this is 7.5. So 30 plus 15 is equal to 7.5 plus the tension in B, which means the tension in B, 45 minus 7.5, which is 37.5 newtons. Or you could take moments about this point here and exactly the same process, and you would also get the same answer.